Try again.
Yes, yes.
Oh, perfect.
Yes, yes.
There you go. Thank you.
Thank you very much. So, very good morning and good afternoon, everyone. And it is a privilege actually to be part of this great international conference as a keynote speaker. I have taken a title which suits to the title of the international conference, because recently Gartner has released the top 10 promising technologies that can disrupt the world. Artificial intelligence and deep learning is one of the mechanism which can disrupt the world that was listed in that list. So choosing this particular topic for discussion, which will enable the participants to create some AI models in the area of various areas, because AI is everywhere. We are living in an artificial intelligence world. That's what I feel, because I have authored a textbook for Pearson Education where the title of the textbook is The Applications of Deep Learning, the emphasis on societal applications. Everywhere, like we are taking applications from civil department, ECE, and it is versatile now. So at some point of time, we will find people with an expertise on machine learning, with a non-expertise on machine learning, because machine learning and artificial intelligence is integral part of our life now. So the presentation is very simple. I kept very simple, like what type of AI deep learning mechanisms exists. The emphasis of the entire presentation will be on what type of applications can be developed by using deep learning, what are there. And if somebody wish to develop a new deep learning algorithm, where exactly he need to have the emphasis. And we need, and there are some other very preliminary part discussions, like what AI is expecting, what is the difference between a traditional system and an AI system, and what exactly is machine learning and various parts of machine learning, what are the pros and cons of machine learning, when can you apply machine learning, when can you apply deep learning. If possible, you'll also see a case study. So coming to the first slide that I have kept, like we have many systems. When somebody wish to develop a AI system or a deep learning system, what the first thing they have to do is either all this, we need to think about this all attributes. Can you design a system which exactly thinks like a human being is very difficult. We cannot replicate the human being structure in a computer. So can you design a system which acts like a human being, is suited, like most of the expert systems or AI systems or deep learning systems fall into the category of acting humanly. And can the systems think without a proper training and testing? The question is no. So obviously thinking rationally is an objective, it's very difficult to achieve. But acting rationally, can the systems after training and testing can think logically, is a objective that this can be achieved. So most of your AI systems that are built already, people are thinking about, will fall into these two categories, acting humanly and acting rationally. Sometimes it is like an example like Sophia will fall in both of them also. So I will go through the applications that I kept for this particular conference, so that that will be more exciting and enlightening. So I have kept a very old system called as Deep Blue, which was implemented by IBM, where this Deep Blue has defeated many world champions like Gary Kasparov and so on and so forth. Apart from Deep Blue, we have many AI systems which implement this chess game, like Rebel, Roval, many other systems are there. But the interest is like how this chess game, like if you say the chess game, we say that it is something like an 8x8 matrix, where how can you predict the move of the opponent based on our move? So you have 32 things that will move from one state to other state based on the certain conditions. So what is the strategy of winning? Like based on our strategy, what is the possibility to predict the strategy of the opponent? Like earlier, we used to remember like there is a standard game called as tic-tac-toe game like this. We call this as a 3 by 3 matrix, where I keep a O here, the opponent keeps a here, I will keep a O here. To defer my winning, opponent will keep a here, and O will be kept here, so on and so forth, until unless we win or the system wins or they go for a draw. So the what type of systems exhibit intelligence? How does these systems exhibit intelligence? And what is the procedure to incorporate intelligence into the system? What is the testing procedure? What is the training procedure? In between, what is the strategy to predict the moves of the opponent is very important in this type of systems, which predict the next move of the opponent based on our move. So I have kept a very advanced system called as Tesla, where the Tesla orientation or the Tesla background is 60 to 70% artificial intelligence and deep learning. So Tesla produces semi-automated cars where they can move from one state to other state, observing the left hand side, right hand side, even the back and the end product. So it will, based on the 4 observations, it can move, it can sense the voice. So what type of mechanisms or what type of deep learning algorithms will support this movement? Like when this car is moving in real time, what guides the car, and how much distance it has to maintain, how it can go for self parking, and what about the observation of the neighborhood, because it has to think about the left neighbor, right neighbor, front and back things. So how does this perseverance will do something like what type of voice mechanisms are there in deep learning to facilitate this? What type of video processing systems are there? So all this, if you analyze, obviously you can understand this artificial intelligence better than anybody else. So I have kept here a humanoid robot called as Sophia, where this Sophia is a humanoid robot which is interacting with 8th class students. It is taking classes, it is interacting with the students, and now the latest version of Sophia can understand the sarcastic laugh of the students also. So how does Sophia at real time can process the video and can understand? How can it process the audio of the students, voice of the students, and can understand and answer the queries? How can it finds the facial expressions and facial movement, and how can it says that it is a sarcastic laugh or some other laugh? So all these are the points that we need to observe when you are trying to design an AI system. What type of models will help you to assess or to process the video at real time? What type of models in deep learning will support you process audio? What type of deep learning models will assess or will help you to process a image? All these are very important discussions when you try to develop an applications of this stature. So we have a very old system called as Mycin, where we call it Mycin is an expert system, where we try to give some symptoms. It will give you the desired or expected disease that can be attributed to this symptoms. But the main emphasis, if you see the latest version of Mycin, what it is doing is, earlier it is used to interact with the people with respect to the text. Now Mycin is interacting with people with respect to voice also. Now if there is a history, like there is a profile of a particular person, this Mycin will predict what type of diseases that he is prone in future also. So a lot of like if you have 6 fingers in the hand, what is the reason for having 6 fingers, and so on and so forth. That is how these expert systems are designed. Earlier expert systems used to interact with people in the terms of text. Now it has the desired characteristics is like we need to just a minute, I will admit this people. We need to have an expert system which process a text, voice, as well as videos. So now in the next slide, just a minute. So AI is everywhere, like even in sports also. If you see the way in which we see a Hawkeye is an AI system, which will try to predict the deviation or displacement once the ball is pitched at real time. how much time, how much height it will travel after it will pitch, and what is the displacement and what is the deviation that it will take in the terms of a realistic image. How does a real video at real time is processed and prediction of happens, like once the ball is pitched, how much deviation it will take, how much displacement it will take, how much height it can travel in the terms of this. All these are deep learning models which will process videos online instantly. So we have seen many applications of this face recognition, even in Twitter or Facebook. The entire processing of these images are done in this face recognition. And particularly now, earlier we used to use MATLAB for processing these videos. Now we are using Python. We have sophisticated modules to process this particular images. So IBM Watson is the most important application where, because IBM Watson was into various fields, health informatics, insurance, and many other places, it has its significance. Where IBM Watson is a question and answer mechanism, where what it will do is it interact with the people in the terms of text. Now people, this IBM Watson is interacting with voice. In health informatics, it will tell like if there is a disease, where exactly this disease is, whether it is inherited from your father or mother, what is the reason for this. So in various type of cancers, you can, if they have the sampling of blood and DNA analysis, it can also give you what type of cancers you are prone in future. Is it a bone cancer, or is it a blood cancer, or is it a breast cancer, or is it a lung cancer? Most of the people now, they are suffering with lung cancers now. So all this analysis can be done. Now they have, we have systems. This IBM Watson is assisting the doctors to prescribe medicines without side effects also. So this type of systems are developed. So everywhere, like you can have a drone technology that is developed with deep learning, where this drone technology used to monitor the crops. It shows the seeds also for that. It shows the fertilizers and many other places. We are using this particular deep learning. And the voice apps, whether you take Siri, Alexa, or Google Home, all these are voice-based app where you can have the personalized searching and capabilities. Every system has its own capability of operating. But my interest is, earlier we used to develop a system which interact with people in the terms of text. Now there is a shift in the nature of the systems. Now they're interacting in the terms of voice. And many of the old systems like IBM Watson, now they are trying to process videos also. Like I just gave a video that I'm suffering with this type of diseases. This IBM Watson is in a position to give me like this may be the attributes of the disease or something like that. So the entire home, like now the entire home utensils, whatever you see, the applications of home are augmented with artificial intelligence and IoT. So we have seen like most of the time, like this is a traditional old problem in artificial intelligence, where we are talking about weather predictions. What type of parameters I have to use, like static parameters, like I have the weather variations of the particular place for the last 1 year. To some extent, I can process and predict. But you consider dynamic parameters like humidity, precipitation, the distance between your earth to the nearest cloud. And based on that, we can also predict the variations of weather in the terms of rainfall, wind speed, and the temperature that we have, many other parameters. Because I need to just, this slide was kept in mind, like whenever you wish to design an AI system, you need to process both the static parameters as well as dynamic parameters. It's very important for anybody to, whenever we are doing that. It is same in the case of stock market prediction also. If I wish to predict what is the variations of stock market with respect to TCS, I can have the data for the last 3 months. Based on that, I can predict. But the stock market prediction is affected with dynamic parameters like news. Based on the news, also the variations in stock market, based on the people recruit, based on the way in which the forums people will interact. Many forums people will interact on talk about stock market. They do sentiment analysis, and based on that also the stock market value change. It takes like it can change with respect to political decisions. So whenever you're trying to design a AI system, you need to keep this in mind, like you have dynamic parameters that will affect the prediction. So when you process the dynamic parameters only, then the system that you are developing will be reliable, and most of the people will use that. Usability will increase, reliability will increase when these dynamic parameters are incorporated. So we spoke about this IBM Watson. So we have very recently, last 1 year, people are talking about CC systems like crowd counting systems. When I visited IIT Madras last year in the month of January, there is a lab where almost six PhD students are working in this crowd counting systems. Like, what is the input for this crowd counting system is like a video, like a CC footage, which is a video will be processed at live, and they will be telling how many people are there in that video. And the most important observation, or the most important output of CC systems is how many people in that video have abnormal actions. These actions will be found based on the training that will be given to the system. And apart from that, how many in this action in general, people will think about how many people will are concerned or are involved in damaging the infrastructure and so on and so forth. So my interest is like a CC system is a system which process videos, and it will give you how many people are on that video, how many people have abnormal actions also. So this type of systems, most of the people now they are using, because they are monitoring the smart cities automatically by using the CC systems now. So if you see the various solutions to this COVID, whether I spoke about lung cancer in the earlier slide, we can have the analysis of CT scan images by using deep learning mechanism, whether you can use a convolutional neural network to process that, and can state that this person is maybe is prone to get COVID in future. And this is the level of the intensity of COVID. All these things can be done by using the analyzing the x-rays of the patients. Apart from that, we have many mechanisms, like in my institute, which is having almost 400 employees. I wish to find out how many people are practicing social distancing. I can take a footage of the CCTV, and I can easily automatically identify how many people are participating and how many are not, how many are practicing and how many are not. Even the same, like I wish to find out how many are having masks and how many are having this mask kept properly. Then we have many deep learning algorithms, like if for this mask detection itself, we have 26 different type of algorithms that are developed, which are adaptable. Even the practicing of social distancing also, we have 16 different type of models that will automatically process a video, and it will give you like these people are practicing social distancing parameters. We have 6 systems which process your CTs scans, standard systems. I'm talking about standalone or benchmarked systems, which can predict what type of people are prone to this particular disease or not. So shopping, like all the customer, like even in Amazon or Flipkart, many of the prominent companies, they are trying to profile, going for a profile, like what type of goods you have procured, based on that, what type of goods you are going to procure in future. All these predictions are happening. So everywhere when you have a market, this artificial intelligence will be there to predict what is the demand and what type of trends this demand is changing, something like that. So in India, it is already in abroad. In India, very recently in March last year, they started giving there is a e-challan mechanism that was started in Kolkata, where you have systems that are, we have national highways. When this national highways, we have CCTVs. These CCTVs are augmented with speed guns, where whenever a particular vehicle is exceeding the amount of speed at some point of time, the speed gun will initiate or excite that system, and the system will take the appropriate video and convert that video into images, and from that images it will extract the car number, and it will send a mail to the corresponding owner based on the car number, saying that this place you have exceeded this amount of speed, so this is what the challan that we have to pay. This is what an AI system, this is what a system that is developed in the terms of deep learning. The same way, everywhere you go for banking or you go for any other real-time marketplace, you have a chatbot which is answering, like Elisa. Like we have a standard chatbot like Elisa, where it will interact with people and it will tell you what is the mindset of the person at that instance or at that time, and so on and so forth. So robotics, we have a lab in Vishnu Group where the robotics is pertaining to 60% mechanical and 40% computer science. We're trying to code the content, and triple E and mechanical people, what they do is they try to design this system, and we try to just code in the terms of the movement, and the hands and all the other things will be prepared by your mechanical department. We have a lab which consisting of 16 different robots that are manufactured and exhibited to perform simple tasks. So health sector, we spoke. Navigation also we spoke, because everywhere when Google is predicting the traffic, and so now the Google is also taking consideration of the road structure also based on the suggestions. So this is whenever we try to think about designing a neural network system or deep learning system or AI system, the emphasis will be like in traditional system, you give an input, you write an algorithm, you get an output. But in neural network or machine learning system, you have the data types, you have the data sets. So you have an input and corresponding output. You need to find a model which will fit for this corresponding input and output. This is the most important thing that you need to keep in mind when people try to develop these AI systems. Most of the people will ask me what exactly this artificial intelligence, what exactly the machine is. So informally, if somebody asks me what is that, I say is, if you wish to apply artificial intelligence, you can implement artificial intelligence by using deep learning or machine learning or neural network. So machine learning can be applied when the data is less and the number of features to predict the data is less. And deep learning can be applied when you have a huge data and the number of features to predict is more. And this is what I will say whenever I have a group of discussion when this is happening. So you have various mechanisms in machine learning where we have a data which consists of the classes. So then it's very easy to find out, predict the things. So we call it as a supervised learning mechanism. When the classes are not known, we need to have mechanisms like clustering, K-means algorithms to predict based on the distance. Many other parameters are there. When the data is not labeled, we have to go for unsupervised learning. Reinforced learning is a learning where we try to take the feedback. Like when you create a robot, we'll try to take feedback at every step and proceed. That type of things are called as reinforced learning. We have few drawbacks in machine learning, like the way in which machine learning performs when the data is more, and the way in which the machine learning performs when the number of features to identify something, identify a features are more. We'll see it in the next slide. These are the famous, very important supervised mechanisms. And these are the list of unsupervised learning mechanisms that we have in the syllabus. And this is where I just try to tell where exactly this deep learning will be used. If you see this particular graph, we can easily understand when the data is more, most of the machine learning algorithms, you have a static output. But if you see the way in which the deep learning algorithms are performing, when the data is more, your performance is also more. That is the reason when the data is more and the number of features to predict is more, then we can go for deep learning. This is what the basic mechanism. Even in my textbook that is authored for Pearson also, I have given almost entire description on what exactly are the deep learning models are available, where exactly you can use, where exactly I can apply or I can combine. Like we have also spoke about, I'm just trying to admit somebody, how I can develop a ternary neural network which mitigates. So these are some examples I just kept. So these are the various models that we have discussed. when I'm just have written this textbook for peers, and many models like RNN, recurrent neural network, the extension of RNN, LSTM, CNN, RNN, GRU, many other algorithms or mechanisms are there. It's very important. Like now people are talking about ternary neural networks in deep learning models, where exactly this model can be applied. And somebody like, I wish to process images. In general, people will go for CNN. I wish to process a sequential data, I will go for RNN. I wish to compare, I have a more sequential data, I will go for LSTM. When the data is less and sequential data is there, I will go for GRU. So many models are there. We need to find out where exactly you can use these models and how can we combine this model to get a hybrid model and so on and so forth.